Greetings to all. I'm Stanley Tadankwa, and greetings to all who are following this recording. Today we talk IPv6 translation techniques. But before we actually get into the translation techniques, I would like us to review the transition mechanisms that are involved with the movement of IPv4 to IPv6. So, like you all know, IPv6 is gradually replacing IPv4, and we must plan properly and we must get transition techniques that will enable this movement. So the very first transition technique is the dual stack, followed by the tunneling, and then the translation, which is actually our point of focus for today. So if you have to maximize this recording, then you should have this background. You should be able to have, or you should have, a basic knowledge of IPv6 address types. You should have a strong familiarity with IPv4, a good understanding of IPv or of IP design in routed networks, and an understanding of how IP addresses are allocated and assigned on the internet. Like I said before, we are going to be focusing on the translation mechanisms, even though we are going to have a brief review of the translation techniques that are involved with moving from IPv4 to IPv6. So the very first translation or the transition technique here is the dual stack, which is actually a mechanism that enable or that ensures that an equipment has a possibility of running both IPv4 and IPv6. So by dual stack, we simply mean the ability for an equipment to run IPv4 and IPv6. A typical example would be Windows 7, for example, which can be configured with an IPv4 and an IPv6 address. So that's a typical example of a dual stack technology. The next transition mechanism here is the tunneling. And if I use an example, you would see here an IPv6 network that is separated by an IPv4 topology. So the two IPv6 topologies have to communicate over the IPv4 topology. And the tendency here is, if the IPv6 packets have to cross the IPv4 topology without tunneling being done, it means that these packets are going to be dropped at some point in the IPv4 network. So there must be some kind of tunneling to enable the two IPv6 networks do a packet exchange. And then the third type, which is actually our point of concentration for today, is the translation. So we have the translation, and we have an IPv6 only network that has to communicate with an IPv4 only network. So there must be some kind of translation between these two topologies. So translation can be done at different layers. We can have translation done at the network layer, at the transport layer, and at the application layer. Sometimes we may decide not to do translation at all. Well, that is not what we should focus on for now, but let's see how translation has to be done at the application layer, transport layer, and the network layer, where IP headers have to be written. So, but the question that should run through your mind is, why do we have to do translation at different layers? We have quite a good number of reasons for that. The first reason here is, you may have legacy applications that cannot be ported to support IPv6, so you need to do translation to translate maybe the IPv4 port numbers to IPv6. You also can have legacy operating systems meaning that you can have operating systems that can only work for IPv4 networks but will not work for IPv6 networks. So you must be able to do translation too at this level. And then you may have legacy equipment, legacy hardware that are only being supported by IPv4 networks but which cannot be supported by IPv6 networks. So you must also do translation at this layer. And an example would be maybe printers, obsolete printers that cannot move or that cannot communicate with an IPv6 topology. So the very first type of, or the very first translation technique here is the NAT-PT, which has a component of ALG. And the peculiarity about this guy is that the ALG, which is simply application layer gateway, and PT, which simply stands for port translation. So the peculiarity about this guy is that the ALG is actually an integral part of NAT-PT, of the technology itself, which means that this protocol or this technology is not only responsible for translating addresses, but it also translates protocols. So it goes beyond translating addresses to translating protocols. And this technology is defined in request for comments 2766. And it works just like the NAT that we saw in IPv4. So if you understand how the NAT in IPv4 works, then you certainly understand how well this guy too works. It uses the stateless IP translation, which we actually refer to as SID. So it uses SID, and SID is defined in request for comments 2765. So we have a sample topology of NAT-PT here, where we have an IPv4 host B, which has to communicate with an IPv6 host. So we should enable NAT-PT at the verge on our router here to enable these two guys to communicate. So NAT-PT has quite a good number of issues. Just like IPv4 NAT, we know fully well that NAT in IPv4 is something we do not appreciate, and IPv6 does not welcome that, and that's why IPv6 has solved that problem by sweeping away the NAT in IPv4. So it has all the shortcomings of the NAT in IPv4. So as a result, it should be considered a last resort mechanism. So you should use this only in cases where you do not have an alternative. The second type, which is actually the recommended type of translation here, is the NAT64 with the component of DNS64. NAT64 has a peculiarity in that it separates the address translation functionality from the application layer translation functionality, or from the protocol translation functionality. You remember, with NAT-PT we said ALG is integrated into the technology, and it translates addresses and at the same time protocols. So, but what this guy does is it has separated the two functionalities, and this is actually giving us so many benefits, and that is why it is recommended that we use this method. And you can implement NAT64 as stateful or as stateless with the characteristics as you see. The beauty too about this guy is that it has the component of DNS64, and the component of DNS64 comes in when you probably have maybe an IPv4 internet and an IPv6 network has to communicate with an IPv4 internet. So there must be a way of translating the DNS information from one network to another. So what DNS64 does is it actually synthesizes the IPv6 records from the IPv4 records. So it's a way of converting IPv4 DNS records to IPv6 DNS records. So this is actually one of the things that makes this technology a convenient technology for us to use. So we have a sample topology, as we can see, which is almost like that of NATPT, but for the fact that we have added some kind of a firewall here, and we are giving specific addresses to make sure that the communication flow. So with that, I think that we have a brief, or we have an overview understanding of how these technologies, or these translation technologies work. I want to thank you for listening. Have a great day.